Hello everyone, so our initial project was to calculate the laminar and non-laminar flow of various fluids using the Raspberry Pi. However, we were unable to accomplish this due to the coronavirus, and we were not able to receive the materials that we needed just due to them not being able to arrive on time. However, the project that we did end up going with is related directly to it, in the sense that this was stuff that we were planning on doing anyways in addition to our original project, and it directly helps with all of the data that we would need to gather from the initial project. So, this right here is the first part of it. It is a bucket with 2 holes drilled on the side and then 2 photoresistors placed on the other side. The holes are for lasers to go through, and so when you drop an object through, as you will see, it will activate the LEDs down here, which are connected to the Raspberry Pi, and that connects to the data. The way that it's set up is such that if the light is interrupted, it will then cause the circuit to be filled with power, recording the time, which will then give us 2 points with the time separating them, and using mathematics, we can then calculate a nonlinear acceleration or a linear acceleration, depending upon what we feel would be best, or both, which we would hopefully have been able to do if we had the available information. The second piece of the puzzle was this piece right here. It's an Arduino with, It's an Arduino with an accelerometer attached and a tilt switch at the top. How this functions is you press the button, and then you see the LED flashing at the bottom. So, you go ahead and you take this, and then you drop it, activating the tilt switch, causing the LED to stop flashing, indicating that it's collecting data, and the red indicates that it has finished. We then connected this to the Raspberry Pi and transferred the information over to compare it side by side with the predicted model of the lasers. As you can see, in particular for the first second, because it's 2 to 3 seconds that it's particularly accurate, since the Arduino only collects data for 5 seconds, 2 to 3 seconds, you can see it lines up near perfectly with the laser. However, once you get to 3 seconds, you see it slowly drop off, and that's due to the physical limitations of it, as we cannot drop it off something that is extremely, extremely high. The ideal plan would be in the future, if we did receive the flow meter or a motor, we would place it in the liquid to calculate the different viscosities, or at least rank them relative to each other, and then test dropping various objects through the liquid to try and calculate the different velocities and accelerations that they have due to the different liquids.